Hello everybody, and welcome to the first episode of Max's Garage. Today we're going to be taking a look at an original Nintendo Entertainment System, or NES, from 1985. Let's get started. Alright, so if you haven't seen one of these before, this is the original Nintendo Entertainment System. It was the first widely produced and successful home video game console that Nintendo ever made, and it single-handedly revived the video game crash that happened a few years earlier in 1983. So without this system, the video game industry would have been much different to what it is today. This NES does work perfectly, but it has one small problem that I'm hoping that I can fix in this video. Let me show you what's wrong with it. So right now I have my NES plugged into my game room TV, which is where it's usually plugged in. And let me show you what happens when you turn it on. When you turn on the NES without a cartridge inserted, you get a bluish screen like this. But notice how in the picture, and I don't know how well you can see this, but there's these ripples kind of just slowly moving down the screen. There's kind of a heavy ripple right here, and then there's a lighter one there, and then in this section here it looks good. And so I don't know if that's normal. I don't have another NES I can test this with, but what I'm hoping is that I'll be able to fix this and have a clean image when it's displayed on a TV like this. And it's not as visible if you put in a game. I'll put in a cartridge real quick and we'll just see how it looks. So if we put in Mario 3 and then turn it on, it's not as visible. You can still see it, especially right here. You can see it since there's bright colors. And this is the problem that I'm hoping to fix with this NES. See if I can make the video quality not have any ripples in it like it has now. So what am I going to be doing to repair it? Well, just to give a little backstory, I've been in this console before. I took it apart and cleaned it just to give it a little inspection and see if everything looks okay. And when I was inside there doing that, I immediately noticed a problem that I knew I had to fix within a matter of time. And I think what I noticed is directly contributing to the ripple issue that you guys saw earlier. Let's take it apart and I'll show you guys what I saw. So I'll have to flip the console to the backside here, and there are 6 screws that hold the top cover on, and those have to be removed. This is before Nintendo switched to the infamous tri-point screw that held all of their systems together. So this console still uses Phillips screws, which is really nice. And then the top cover comes straight off like so. So here's the first look at the inside of the NES. And just by looking at it, it's not really the easiest thing in the world to tell if there's a problem, because everything's covered by metal shielding. There's not really much to see at this point. So this is where the cartridge goes in here. This thing snaps down when you put in your cartridge, so it makes contact with the little connector in the back. Your 2 controller ports here connect with these wires to the underside of the motherboard. And then this little squarish thing right here, this is the RF modulator. It's responsible for producing the video output from the system if you hook up to RF or composite, which is what you saw earlier. But fortunately, we don't have to take apart this console any further to see what the problem is. If you take a look at the RF modulator, you'll notice that there is a big capacitor sticking out of it right here. And if you take a closer look at that capacitor, something about it seems off. Now, if you're not very experienced with the electronics, this capacitor might look totally normal to you. But it isn't until you look at it at a different angle, like flat on like this, you can see that the top of the capacitor is ever so slightly bulged out. And that's what happens when capacitors fail. It doesn't happen like that all the time, but that is a telltale sign that this capacitor is failing. And as I said, this capacitor is directly inside the RF modulator, which is responsible for handling the video output. And so that's what I think the problem is. This capacitor's failing, and that's what's causing the ripple that you're seeing when it's hooked up to a TV. So let me try to explain as to why I think this capacitor is causing the problem. So when capacitors start to fail like this, It's because they have something called an ESR, which stands for equivalent series resistance. And when capacitors are first made, that number, that ESR number, is quite low. And over time, this number starts to get higher because the capacitor ages. And when this number gets higher, the capacitor starts to not be able to hold as much of a current as it used to, and that can cause weird side effects with certain aspects of an electronic device. And once the ESR number starts to grow and the capacitor can't hold as much as what it used to, then what happens is the capacitor will get hotter than it was originally designed, and it can start to bulge like this due to the gases changing inside due to the excessive and unwanted heat. So I have pretty fair reason, I would say, to believe that since this capacitor is starting to bulge a little bit, it is on its way out, its ESR is higher than it should be, and that it is contributing to the ripple problem. So to remove the RF modulator and get to that capacitor, we'll have to take apart the rest of the console. Let's keep going. I've had this bit out before, and I remember it's kind of hard to get this out, so bear with me for a sec. There we go. So that was the cartridge slot system that I just removed. And when I originally bought this system, whoever owned it last replaced the actual cartridge connector. It comes off the motherboard because it's typical for these to fail over time. This is the only NES I've ever owned, so I've never come across this, but this is not an original slot connector, so this has been replaced. So we still have some cable connections that we have to unplug, but now the motherboard and RF modulator should be free, and it looks like they are. And there we go. And I think this bottom shield is free as well. It is. So this is the NES motherboard. So if you're wondering, this cartridge connector, I said it comes off the motherboard. If you go to this side, there's a slot connector right here, and this just slots into the motherboard like that. So it's pretty easy to replace once you get the motherboard out. So taking a closer look at this motherboard, you can see it has a copyright date of 1987. So this must be a later revision of the NES motherboard. And taking a look at some of the chips on the board, like this one here, it says 8932 on it. That's a date code. So that would be the 32nd week of 1989. This chip says 8941, so the 41st week of 89. So clearly, this specific NES was made around mid to late 1989. That would be 2 years before the Super Nintendo came out. So right here, this is the RF modulator. I've never looked inside here. I've never seen if there's any other components in there that looked suspect. Everything here that I'm seeing looks good. As you can see, there's little capacitors here. Those all look good. I can test them to see if they are good. In fact, that's a good idea. There's only 3 electrolytics. These are electrolytic capacitors. These are a different type. These are little orange things. These are also capacitors. These are ceramic capacitors. I couldn't think of the name off the top of my head. But let's test the 3 electrolytics and see if they're actually good. And what we'll be using to test the capacitors is this. This is an ESR meter, so we can test the capacitor's ESR value directly and see if the capacitor is, in fact, good or bad. So we'll hook up the 2 clip leads to it. We'll turn it on. Make sure it's zeroed out. It is. So when testing one of these capacitors, you have to know which side is the negative and which side is the positive. It'll be marked on the actual cap. So for this one, it is on the farther back side. So this one right here, closest to you guys, is the negative. Actually, what value was that cap? 100 microfarad at 6.3 volts is what that is. So this ESR meter has a little table on it saying the worst case ESR value for certain types of capacitors. So this one only goes down to 10 volts. 100 microfarad for a 10 volt capacitor its worst case scenario would be 1.2. So I would expect it to be below 1.2 if it was a 10 volt cap, but this is a 6.3 volt cap, so I would expect it to be quite a bit lower than 1.2. This is a plastic meter, so it's not shorting anything out when I put it on the board like this. 0.5, 0.6, that capacitor is definitely good. And this one is right next to it. I imagine it's the same capacitor. No, it's not. 50 volts, 2.2 microfarad. It doesn't even have 50 volts. Oh well, we'll just test it. We'll see what it is. 3.07. Okay, I found online, I'm just looking at my computer off to the side here, another ESR table that has a lot more voltage values and capacitance values. And so I can see here 2.2 microfarad, 50 volt. The worst case scenario would be ESR of 4. So that capacitor is good since it was reading 3.05. So that one is good as well. This one is a 50 volt 1 microfarad capacitor. And so this one, the worst case ESR according to what I'm looking at, would be 5. So I would expect it to be lower than 5. And that is here on the board. Lower than 5, lower than 5, 4.34. So that capacitor is good as well. So there you go. That's, if you have an ESR meter, it's pretty easy to test capacitors in circuit to see if they are good. So now we know these 3 little electrolytic caps are totally fine. All right, time to take a look inside the RF modulator. Now, initially, I thought I was going to have to desolder it, and I might still have to. It looks like these 4 points and then these 5 connections here would desolder it from the board. But it looks like on this side, this back cover here looks like it can come off. It doesn't look like it's soldered onto anything. See if the iFixit spudger can help pry this cover off. And there is the underside of the RF modulator. And I believe that these 2 leads here are the capacitor leads because they're both the same size and they're spaced apart like how a capacitor would be. That is definitely it. So let's test this and see if it actually is failing or not. And the value of that cap is what? 2200 microfarad, 25 volts. So let's look at that table. Worst case ESR, 0.06, so very low. So when I test this cap, I should see no higher than 0.06. Our reading is 0.5, not 0.06. So there it is right there. The ESR is higher than it should be. And that means this capacitor is definitely bad. This ESR meter has a 25 volt reference, I guess you can call it, in it. So it'll tell you right on the display, it'll say like reference for a 25 volt cap. Good if it's less than a certain microfarad. So let's see what it said. It says good if cap is less than 200 microfarad. This cap is 2,200 microfarad. So this cap is definitely not good. So that proves my point in saying I'm pretty sure that cap is causing our issue. And so what I've done before even testing the cap is I went online and I ordered a 10-pack of brand new 2200 microfarad 25 volt capacitors. And whenever I buy new capacitors for things, I typically buy them in lots like this so that when I need to use a certain amount, I always have spare ones left over for other things. So in this case, I bought a 10-pack and I only need 1. So let's take one of these capacitors out and let's test its ESR because this is a brand new cap. So the positive lead is this one and the negative lead is the other one. And what is our ESR? 0.08, that's a little bit higher than 0.06, but way better than what we were just testing with the other one. So this capacitor is definitely okay. So what we need to do at this point is clean up the workspace a little bit and desolder this capacitor. Yeah, I'm getting no heat transfer at all, so I'll have to use the pump. There we go. Now the solder is melting. Slowly but surely it is melting. I'll turn the temperature on this thing up to 425. See, that sucked a little bit of it. I didn't have the best angle on that, so it didn't suck at all. There's more. With these pumps, you might have to do it a few times simply because you have two things working with the solder at once. I should say, I have a tiny little bit of my good wick left. Let's see if we can get something happening. I took it out of its plastic case just because I had so little of it left. But I have to be careful when doing it this way because this wick will heat up very fast. Yeah, I am definitely getting it to melt now. Let's get to work on the other one. I can probably pull the cap out from behind since I can put my two fingers on the cap. So once both of the leads are melted, I can just pull it right out. So let's see if we can do that. There we go. I just pulled this one out. Let's do the other one. That one's out. Maybe this one's not totally there yet. There we go. There's the old cap out. So here's the old 2200 microfarad 25 volt cap. It actually looks good on the bottom side. It hasn't physically started to leak out its electrolyte yet, but it is bulging at the top, so it's time for this to get replaced. And since there's still a little bit of the lead left on the cap, the old cap, let's test its ESR and see if it changes any when it's out of circuit. And what do we have? We have 0.2, so it's definitely higher than the 0.06. You can see it did change when it was out of circuit. And that's the thing with testing stuff like capacitors and resistors in circuit, is that it's not always accurate. There might be more voltage going to the rest of the motherboard when you do it in circuit, which might change the reading of your meter a little bit. So now what we want to do, actually, I'm going to take a look at the inside of the thing there. Maybe a little bit of leakage has happened. I can see a little bit of residue where the cap used to be. But because I see a little bit of residue there, I'm going to clean that real quick with a Q-tip and some isopropyl alcohol. Hang on a second. What is this? Where did that come from? What is that? This was inside the RF modulator when I was cleaning it. It looks like it broke off of something? I don't know what this is. It's a piece of metal. It wasn't from the cap, I know that. Yeah, and just like that, that residue is completely gone. So obviously something in that old cap started going wrong because my Q-tip is slightly discolored. So before I stick that new cap in there, what I need to do is I need to clean up the pads there so that you can actually see the holes, and that'll make it so I can actually put the capacitor through the holes so there's not solder on top of them. To where it looks like that. There's a tiny little bit of solder still there, but the hole is completely exposed, so now I can actually fit the lead of the capacitor through it. So now I have to do the same with the other one. This wick is amazing. This was a Radio Shack branded wick, so you know it's good quality if it's made by them. And there we go, there's the second one. So now that those are cleaned up, we can go ahead and put the new capacitor through those holes. So that's gonna go in just like that. This capacitor isn't as thick as the original, so it's not gonna go all the way in, but about right there. And I'm gonna make sure that stays nice and steady as we flip it over to the back. And I'm going to fold the wires down like this so it does not move while I am soldering. And that's typically what you do when you solder in through-hole components like a capacitor like that. Here's the first one. Come on. And there we go, there's our second one. So that capacitor is now soldered into place. Just gotta cut those wires off. Oh, that one almost flew in my face. So there you go. Brand new capacitor soldered in. Let's take a look at the top and just see. It's not perfectly straight, doesn't need to be straight, but it looks better if it is. So there we go, there's the new capacitor. So now all we have to do Let's put the console back together and we'll see if our ripple problem is fixed. I'm sure not all of you watching are super into electronics like I am, but the least I can do is teach you a good technique to use when screwing a screw back into something, because I imagine that all of you will have to do that at some point for something. So when you're screwing the screw back in, especially if it's going into a plastic standoff like these, if it's going into plastic threads, you don't just want to start tightening it right away after you get it set in there, because what might happen is the screw might not be back in its original threads yet. And so when you tighten it, it'll start making new threads in the same plastic, and that could damage the plastic depending on how exactly the screw is going back in. So what you want to do to avoid any problems and have the screw go back in the threads that it was already in is you want to get the screw set in there, and then you want to loosen it until you hear it make a little click noise like this. You can hear that? That's the sound of the screw setting back into the original threads it was in. So after you hear that, then you can start tightening. And you'll notice that if you tried to screw in the screw the first time, you'll notice it's a lot easier to get the screw to actually go in because it's going into the threads it's already been in. So that will help you avoid any problems when screwing screws back in. And you can also use that technique when you're screwing back into metal threads just to make it easier on yourself. Loosen it until you hear it set in and then tighten it. And as I was screwing the cartridge holder back in, I thought of another screw technique that I thought might be useful. So when you're working with multiple screws that screw in one thing, like this cartridge holder has 6 screws, when you screw in like the first set of screws, you don't want to over tighten them or completely tighten them initially, because what will happen is if you have like flexible plastic, for example, and you over tighten, like here's an example. Say you have a flexible piece of plastic between this screw and this screw, and that's all it is, just a little flexible piece. If you completely tighten this first screw, the plastic will bend outward, it'll bend up on this side because this screw is tied too tight. So what you want to do to avoid that is when you screw in the screw, you want to screw it into like about until the point where you can just feel the resistance starting, like maybe even a little bit before that, to avoid that bending issue. Because if I over tightened this screw, it might be hard to screw the screws on this side back in because it might be bent upward a little bit. So that's another technique. If you're dealing with multiple screws, just screw them in until they're pretty much all the way in, not tight. And then after you're done screwing all the screws in, then you can go back and tighten each one. So that's another thing that I think is important to know when you're dealing with multiple screws that screw in one thing. So like this screw here, I'm not going to tighten it completely. I'm going to get it just before that point, so about right there. So there won't be any issues of bending or struggling to get the screw on this side in just because it's not tight. Okay, so at this point, I'm ready to put the top cover back on, and then it'll be completely together after I screw it in. But there's one more thing I want to do to this console before I seal it up, and that is with the door that you open to put in a cartridge, it squeaks. So I think I'm going to put some lubricant on that before I put the cover back on, just so I don't have the squeak. So when looking at the door mechanism, I see that it rubs against these 2 little pieces of metal that I can unscrew. So they're just 2 little flathead screws. And that's the sound a screw makes when it's never been removed. I'm just glad those are screwed in and not glued in or riveted in so I can actually access them. All right, I have my thing of dry lube. And what I'm going to do so I don't spray it all over the inside of this cover is I'm just going to spray it on the end of a Q-tip. And then we'll apply it that way. So I'll take it and we'll spray a little bit on the end of this Q-tip, like that. And now we'll just go in and gently apply it to that plastic right there. And then we will open the door. Actually, it is open. We'll close the door. We'll do the same again. Okay, those are back in. Let's see if the door still squeaks. A little bit. It's better. So I'll put a little more lube in there. Okay, listen to this. Absolutely no squeak. And the door feels a lot smoother too. Like, I've never felt it this smooth. So it was definitely a bit gummed up before I lubed it. Perfect. I'm gonna go ahead and put the top cover on the system, screw it on, and then we can go test it on the TV. Okay, we now have the NES hooked back up to the TV in the game room. So let's turn it on and see what our video output's like. Oh, we still have ripples. I kind of expected that. All right, camera off tripod moment. So what I did was I brought in my little monitor that I keep on my desk for testing stuff. I brought that in and I hooked up the NES to it using a different video cable. And if I turn it on, you'll see there are absolutely no ripples on the screen. And because there are no ripples on the screen, I put a game in, like Super Mario Bros. 2, turn it on, it looks absolutely flawless. No ripples of any kind. So it just must be the TV that displays it a bit weird. So I just had a thought. What if this ripple problem was caused by the cable that I've been using this whole time? Because it just worked on that little Polaroid TV. So what I did was, this TV has a free AV input on the left side, so I hooked the NES up with that same cable I was just using to that input. And that reminds me, I have to switch the TV to that input or else it's not going to work. So let's turn the NES on now and see what it looks like. Oh my gosh, it was the cable. Look at that. It looks perfect now. So it was the cable this whole time. Let's go to a blue screen and then we can clearly see that. Yeah, that's what it should look like. It's just a standard image with no bad effects. Obviously, the cable I'm using is somewhat defective. So I hooked up the cable I was using, and look, the ripples are back. So that definitely proves that the cable is screwed up. So I'll have to go behind the cabinet and replace that, which thankfully is easy. I have a bunch of those cables, but that goes to show you should really troubleshoot all of your external sources before going in and diving into the console. But I do have to say that that was a good repair that I did, because you saw that original capacitor was starting to bulge, which meant it was on its way out. It had a higher ESR value than what a brand new capacitor of the same type had, and it had started leaking a tiny bit on the bottom of the motherboard. So it definitely needed to go anyway, even if it wasn't causing the problem. So that repair I just did prevented the console from having any serious capacitor leakage problems in the future. So I am glad I changed that. That was on my to-do list for a long time. And I'm also glad that the door doesn't squeak anymore. It's perfect now. So yeah, we found out what the real culprit was. A defective video cable. Good thing it uses a standard AV cable and not some proprietary cable like the later Super Nintendo used. So that will be very easy to swap out. Okay, so I went behind the cabinet and I replaced the video cable for my NES, and I've been playing Mega Man 3 for a little while now, and I'm happy to say that the video output still looks absolutely perfect. It's really nice to play games on this thing now that there's no ripple. And this right here is just an artifact from the game, that little flicker. Some NES games are like that, so that's totally normal what you're seeing. So it was definitely a wild ride to get this console to a point where it actually looked perfect. I hope you enjoyed going down that road with me. Thank you for watching, and I'll see you guys in the next video.